Alright, hello everyone. So in this video what I'm gonna do is I'm gonna explain how to use an initial condition to get a unique solution in a problem where you have a system of differential equations. So here we have the system of differential equation. Let's write it like x prime is equal to a is going to be, let's see, -2, -2 and -1 and -3. So that's from here and here times x. So that means our matrix A is -2, -2, -1 and -3. Perfect. Now to save time, what I'm going to do is I'm going to give you the eigenvalues and the eigenvectors. Okay, so the eigenvalues are going to be lambda 1 is -1, lambda 2 is -4, and the associated eigenvectors are -2, -1, and for k2 it's 1, 1. Alright, so we know the eigenvalues and eigenvectors, and we can write the general solution as C1 -2 1 e to the -t plus C2 1 1 e to the -4t. Right, that's the general solution. Okay, now let's say we have given an initial condition like this. Alright, oops, okay, 1 4, perfect. Now how are you going to find a unique solution out of this general solution using this initial condition? What I meant is, how do you find C1 and C2? It's very simple. Now the meaning of this initial condition is that when simple t is 0, okay, you get 1 4. Now there are two rows, okay, so this is a 2 by 2 system. Okay, 2 by 2 system, and you get a 2 by 1 eigenvector. That means 2 rows and a 1 column. So really this xt is an expression of 2 rows and a 1 column, right? Because you have 2 rows and 1 column, 2 rows and 1 column. When you add that, you get 2 rows and 1 column. So that's why you have 2 rows here in the initial condition. So let's substitute t is equal to 0 to the right hand side of this general solution. So it's c1 -2 1 e to the 0, okay, -0 is same as e to the 0, c2 1 1, this is also e to the 0, I mean -4 times 0 is 0, and the left hand side is then 1 4. Okay, so 2 rows. Now let's simplify the right hand side. E to the 0 is 1, e to the 0 is 1, so basically this is, oops, c1 -2 1 plus c2 1 1. Now this is addition of two vectors. Let's add them. Well, first, okay, let me back up. Let's multiply by c1, the first vector. So it's going to be -2 c1 here, plus c2 here. Right, when you multiply by c2, 1 1, that's what you get. And the left hand side is 1 4. Okay, then now we can add these two vectors. So if you add the first row, you get -2 c1 plus c2, second row c1 plus c2. So you add the corresponding rows, and then this is equal to 1 and 4. Now see, you have two unknowns, c1 and c2, and you have two rows. Out of these two rows you can get two equations. So if you compare the first row, it seems to be like 1 is equal to -2 c1 plus c2, and if you compare the second row, it seems to be like 4 equal to c1 plus c2. Here you go, you get two equations and two unknowns. Now from here you can solve for c1 and c2. Let's say this equation is 1, this is 2, so let's subtract 1 by 2. So 1 minus 4 is equal to -2 c1 minus c2, c2 minus c2, that's cancelled out. That's why actually I subtracted them off. So it seems to be like -3 is equal to -2 c1 minus c2 is -3 c2. So c2 is 1. Okay, no, not c2, c1, right? c1 minus -2 c1 minus c1. I made a mistake. So let me tell again, -2 c1 minus c1, c2 and c2 subtract, it cancel out. So this is -3 c1. So c1 is 1. Okay, -3 divided by 3, c1 is 1. So c1 is 1 means by second equation c2 is going to be 3. Now we can write the final solution, the unique solution. Xt is equal to c1 is 1, so you don't have to write 1 there, so it's -2 1 e to the negative t. C2 is 3, so it's 3 times 1 1 e to the negative 4t. This is the solution. Okay, so that's how you use an initial condition in a system of differential equation to find the unique solution. Okay, all right, thank you.